This video is for the last two sections of the note sheet 8.1, variation functions. We're going to find out how we can identify direct and inverse variation from a table of values. We start off with the formula or relationship for direct variation y equals kx, and we solve for k, realizing it actually creates a constant ratio where we will take the y value divided by the corresponding x value, and if all such ratios produce a constant value, then we could state that table of information is related by direct variation. For inverse variation, we start off with the formula y equals k on x. Solving for k results in a constant product. So if we multiply the x and y values together, and in each product pairing we produce a constant value, then we could state that the table of values represent inverse variation. So identify the type of variation by solving for k. So with our first example, I will first check out and realize pretty quickly that if I multiply these values together, I'm going to get a constant value for each of them, because 6.5 times 8 is equal to 52. 13 times 4 is 52, as well as the last product. And since each of these resulted in the same constant product, where the x and y values multiplied to a 52, where that's the k value from up above for over here, I could then say with a constant product I have inverse variation. And you could look at the table of data and quickly see that as so here y is larger than x, but in the next pairing x is larger than y, and that's the idea with inverse variation. As one increases, the other decreases. So then, whereas the one's increasing and the other decreases, that's to compensate for the other, and it will still result in a constant product. Looking at the next table of data, realizing right away that if I take 5 times 30, I'll get 150, and 8 times 48, that's about 50 times 8, I'm way over what 5 times 30 equals. So I don't think it's going to be inverse variation this time. Instead, I'll look at their constant ratios, taking the bottom one, the y, and dividing it by the x. (30 on 5 simplifies to 6. The next pairing, 48 on 8, simplifies to 6. And 72 on 12 simplifies to 6. Since the ratio is constant, I know I have direct variation. Keep in mind this whole time, save for the previous example with inverse variation, I'm basically considering this relationship. So if I take both sides and multiply it by x, then I could solve for my constant variation k, so they multiply together to equal constants. What does it look like if you take two types of variation and combine them together? In this example, quantities that vary directly appear in the numerator, and quantities that vary inversely appear in the denominator, which should make sense because for direct variation y equals kx, for inverse variation y equals k on x, for inverse variation the variable is in the denominator. For direct variation the variable is in the numerator. So for this example, the change in temperature T of an aluminum wire varies inversely as its mass m and directly as the amount of heat energy E transferred. So step 1 will be to find K. We will set up the relationship as T equals, looking back at the problem, it says that the T of an aluminum wire, temperature, varies inversely as its mass. So then that means the m will go in the denominator. And directly as the amount of heat energy E transferred. So then that means E goes in the numerator. And notice, no matter whether we are looking at direct variations equation or inverses variation equation, K is always in the numerator. The next sentence gives us initial values to solve for the constant variation K, stating that the temperature of an aluminum wire with a mass of 0.1 kilograms, that's the denominator, rises 5 degrees Celsius, so that's the temperature, when 450 joules of heat energy, that's our E value, and we want to solve for K. Multiply both sides by 0.1, or you could divide by 1/10, which makes this 5 equals 4,500, and then dividing through and simplifying for a K value of 1 on 900. Notice no units, it's a constant of variation. Step 2 is to use the variation function. We now substitute in with the K value known. T equals 1 on 900 E over M. In the second batch of information, it says how much heat energy must be transferred to an aluminum wire with a mass of 0.2 kilograms to raise its temperature 20 degrees Celsius. So temperature is 20 degrees Celsius. We are looking for the E value, and the mass is 0.2. Simplifying on the right-hand side, 0.2 is the same as 1/5. Dividing by a fraction, you multiply by the reciprocal. So 5 on 900 simplifies to 1 on 180. You could also just use a calculator. And when we multiply by the reciprocal, we find that the amount of heat energy in joules is going to be 3,600 to raise the wire 20 degrees Celsius when its mass is 0.2 kilograms.